This is lesson 83. Find trig values. It's going to kind of tie together what we've already done to make for a little bit different lesson. And that'll be 170 and probably just going to be 170, but I'll mark it 170 and 171. Okay, let's go back and review just a little bit. We know that the three trig identities that we use are sine, so, opposite leg over hypotenuse, cosine, adjacent leg over hypotenuse, and tangent, opposite leg over adjacent leg. So let me find my ruler, and let me show you how the problems are going to be set up. There is not a picture drawn, and I'm going to draw a generic picture the same every time so that I don't have to think about where I'm putting my information. Let me show you where it's going. It says find the sine. Okay, now you're going to have a new notation. Instead of saying angle A or angle B, it's going to call the angle theta, and theta is a Greek of your Greek alphabet. Now, it's the small letter. You're usually used to theta in sororities and fraternities being a capital T. It really looks like a T. And the theta for the little letter kind of looks like an O with a little bit of a curl to it. So, and I'll show you how we label that in just a minute. So it says find the sine of theta if the cosine of theta is 24 over 25. So I'm going to draw me just a generic right triangle. And I'm going to draw it the same every time. They don't give me one. I need the triangle, and I really think you will want it too. But I'm going to always draw it like this. I'm going to put my right angle here since they don't give me one, and I'm going to put my theta right here every time. And then that'll just make it easier. So what do we know? We know the cosine of theta is 24 over 25. Well, what are those two numbers? It is the adjacent leg and the hypotenuse. Well, in my triangle, if my theta is right here, there's the opposite leg to theta, there's the adjacent leg to theta, and there's the hypotenuse. So if the adjacent leg is 24, that's this one. If the hypotenuse is 25, that's this one. Now, do I have enough information to find the sine of theta? So the sine of theta would be equal to the opposite leg, C, that we don't know, so we're going to call that our x, over the hypotenuse. So we know it's going to be something over 25. So how are we going to find this? Well, we know the Pythagorean theorem when we have a right triangle. So Pythagorean theorem is a lot of basis in trigonometry, even though we teach it away from it. So I know that leg squared plus leg squared equals hypotenuse squared. And I've already got these numbers worked out, so we'll wade through the arithmetic. I've got x squared plus 576 is equal to 625. Subtract 576 from both sides, and I get x squared equals 49, square root, and I get x is 7. So now for theta, the opposite leg for sine is the 7, which is the opposite leg, over the hypotenuse, which is 25. Now sometimes these will have to be reduced. In this case, you were finished with it. Let's do one more. Find the cosine of theta if the tangent of theta equals 3/4. Now that's a pretty simple triangle. If you think about it, you may already know what the other side's what the unknown side is, but we'll wade through the arithmetic anyway, just in case you don't remember it. See, I'm going to draw the same triangle every time. I'm going to put theta here, put the right angle here, and so if the tangent of theta is 3/4, tangent is opposite leg over adjacent leg. So which leg? Here's my two legs, and the opposite one from theta is the 3, see? And then the adjacent one is 4. So if you put your theta here every time, this will be the adjacent leg, That will be the opposite leg, and then this one will be the hypotenuse. Now that's your easy Pythagorean triple. You should know what x is, but we can wade through the arithmetic if we need to. So we've got leg squared plus leg squared equals hypotenuse squared. 16 plus 9 equals x squared. X squared equals 25 square root, and so x is 5. So you probably should have known that one anyway. That's that easy one. So what do we have now? We need to find cosine of theta. So cosine of theta is adjacent leg over the hypotenuse. Well, the adjacent leg we already knew was 4, but now we know the hypotenuse, which is 4/5. Now in this case, this again is one that was already reduced. Sometimes they will be, sometimes they won't be.